So, students, today let us try to find out the HCF and LCM of polynomials. Let us say we are having three polynomials x minus 2, x square minus 4, and x minus 2 square. Let's try to find out, first of all, the HCF of all the three. Now, we know that HCF of 2, 4, 8 would be highest common factor, would be 2. How do we get it? What are the factors of 2? 2 into 1. Factors of 4 and 8, we know that. Now, we'll take a common factors. The common factors are 1 and 2. And what is higher out of these two is 2. So, 2 is the HCF of 2, 4 and 8. Am I right? Similarly, if you want to find out the HCF of these three, you have to know what are the factors of these. So the factors of x minus 2 is same x minus 2. The factors of x square minus 4, this is like a square minus b square. It's like x square minus 2 square, right? So this is equal to x plus 2 into x minus 2. Now, you see, I can observe that x minus 2 is coming common in these three. Is it coming common in the third one also? Yes, it's there. X minus 2 whole square can be written as x minus 2 into x minus 2, right? Now what is common in all this? You could always say this is multiplied by 1, this is also multiplied by 1, this is also multiplied by 1. So common thing in all these three is 1 as well as x minus 2. Okay? So, now if I just ignore 1, I can say that x minus 2, considering this to be bigger, is the HCF, is a common factor. So x minus 2 is the highest common factor of these three polynomials. We need not, take this seriously, thinking that x minus 2 may be less than 1, so 1 is the HCF. No, you will say this is the HCF. Now, guys, how do you find LCM of these three? In order to find LCM of these three, we again try to recollect that what is the LCM of 2, let's say, and then let's say 2 into 3, and let's say 2 square. How do you find the LCM of these? So LCM of these, when you want to find out, you have this method, like you write here 2 and then comma, and then you put 6 and then comma, and then you put 2 to the 4. So similarly, how you do this, you can do this one also. You divide all this by 2, 2, 1 is 2, 2, 3 is 6, and 2, 2 is 4. Now you need not unnecessarily divide them by again 3 and 2 to get 1, 1, 1. No. There's no common thing except 1 between 3, 2, and 1. So leave it here. LCM is 2 into 3 into 2. This will save time. So 2, 3 is 6, 2 is 12. Simply, this is the LCM. So you do the similar thing here. Like right here, x minus 2, first term. Second term is x squared minus 4. Write down the factors of this. This is x minus 2 into x. Sorry, it's not 4. This is x plus 2, right? And the third term is x minus 2 into x minus 2, right? Now, just like you do this one, you could do this one also. You simply divide by what? Now, you don't waste time dividing this by 1. That's the same thing will come. So tell me, students, these three terms, I should divide all the three by what? What is common in all these three?
X minus 2.
Very right.
X minus 2.
So here, when you divide x minus 2 by x minus 2, what do you get? Here, what will you get?
1.
Right. Here you will get x plus 2. This is
X
and here
plus 2.
x minus 2. Now, similarly, like what you would used to do here, 2 into 3 into 2, because there's nothing common between x minus 2 and x plus 2. So LCM will be simply x minus 2 into x minus 2, that is x minus 2 square into x plus 2. So you could always solve them and get the answer. Interesting. Let's do some more sums on this, students. So somebody can ask you, these two polynomials are given. One polynomial is x plus 3, linear polynomial. Other is quadratic polynomial x squared plus 8x plus 15. Now, again, we want to find the, let's do the easy thing first, HCF, highest common factor. So we know that on the back of our mind, x squared plus 8x plus 15 by middle term splitting, you could always get, you can always understand that this is, 5 plus 3 is 8 and 5 into 3 is 15, right? So it will be x plus 5 into x plus 3. These will be the factors. When you again multiply, you'll get 8 square x square plus 5 plus 3 8x plus 5 into 3 15. So I have x plus 5 into x plus 3 and the second term is x plus 3. Am I right, students? And now you see, uh, I've got these two terms. So what is highest common factor? Highest common factor, tell me students, of these two terms, what will be HCF?
X plus 3.
X plus 3, beautiful. X plus 3 will be the HCF. Okay. All right. Just like the students are listening to the video, learning for the first time, these students who are answering are also learning for the first time. So now when you want to find LCM, you go the same way. How? Right here, x squared plus 8x plus 15 and x plus 3. It could have been better if you could have written, instead of this quadratic polynomial, x plus 5 into x plus 3. But it's okay. Now tell me, these two should be divided by what, students?
X plus 3.
They should be divided by x plus 3. Why? Because we know this is common. Now let's say it's like you have 5 and 10. So you will not divide by 2 because 5 is not getting divided by 2. You'll divide by 5. 5 1 is 5, 5 is 10. Similarly, you'll divide this by x plus 3. When you will divide this polynomial by x plus 3, what will you get here? You will get x plus
3.
x plus not x plus 3 because this is not x plus 3 square. You will get x plus
5.
beautiful
5.
When you will divide x plus 3 by x plus 3, what will you get?
1.
Now you need not go further. It is waste of time. You just write here x plus 5, then you again write 1. Waste of time. Multiply this by this by this. All right. So what will be the LCM, students? It will be x plus 3 into x plus 5. This is equal to x squared plus this one. 5 plus 3 is 8, x 5 into 3 is 15. So the first polynomial is the LCM of these two and HCF is x plus 3. Right? Well, you might think, sir, why we are doing this? We could have simply guessed that this is the LCM of both these. Well, you might have 3 or 4 terms also. So this method is better. Okay? Or if you can just judge from here, fine. Let's do one more sum. Let's say somebody says, what is the LCM of x plus 3, x plus 1, and x minus 1? Now, nothing is common in these. So, just like you have 2, 3, 5, if you want to get the LCM of these three, what will you get? What do you do normally when nothing is common except 1? You do 2 into 3 into 5 to get the LCM. That is equal to 5 is the 15 to the 30. Similarly, students, what will you do to find the LCM of these three where nothing is common? Yes, any student? What will you do to find the LCM of?
Multiply all 3.
Beautiful. So that is Monroe's deep chord. X plus 3 into x plus 1 into x minus 1. So we have students here of 9 who are competing with 10 students. Why? Because it's like maths. You cannot understand whose brain is developing at which stage. So 9th and 10th and 11th, it's all academic issues. But when you're teaching, it all depends upon how well you understand. So and then you simply multiply all these things, then you get the answer. And students, what will be the HCF of these three? So we don't know, we cannot guess.
1.
Nothing is common.
1.
We just end up saying HCF is 1. And did you enjoy, students?
Yes, sir.
We're learning about
Yes,
LCF,
sir.
HCF of numbers. And now you know how to find LCM and HCF of polynomials. Interesting. Thank you.